Hello, everyone. My name is Nathan Peck. I work as a developer advocate at AWS, and today I'm happy to be here for the container office hours, and I'm going to be live building an application and deploying it to AWS. So first of all, let me start out with a little introduction to what the application is that we're going to be building. And what we're going to be building is a web application that takes a screenshot of a web page and then returns back the URL of that screenshot. So a couple different components. We have an API we'll be able to submit an API URL to, a background worker that will take a screenshot of a web page, and then it will return back the URL of that web page. Now, this is something that I've built a few different times over the years for different startups, and it's turned out to be something that's very useful for a lot of different use cases. I want to show one example of what you can accomplish with an application like this. So I worked at this startup Airtime, and one of the things that they have as a feature is a social media share page for your user profile. And if I go into the source code, you'll see something called an OG image. That stands for Open Graph Image. And one of the asks from the product team when I was working on this particular feature was that they wanted to have a robust share image for social media. And you can see that it looks something like this. There's obviously a lot going on in that image, but the important thing about it is this had to be generated on the server side. So whenever somebody shared this page on social media, we needed to have an image that would be embedded on their Twitter, Facebook, whatever social media was shared on, that had the user's profile name, image, different details like number of friends and rooms here. And this had to be dynamically generated by the server. So there's a lot of different ways that we could approach developing this. I could have chosen to composite an image myself on the fly, but that's pretty complicated. I mean, you can see that there's some gradients in there. There's actually a gradient on that text that says join me on Airtime. There's rounded corners and stuff like that. So it would be pretty challenging to develop a process that could draw this type of image on the fly on the server. But web browsers are very good at doing all of these different things. So I chose to implement this as an HTML template built using HTML and CSS, and use a headless web browser to take a screenshot of that web page anytime we need to generate this. And so this gives you a lot of flexibility. It allows you to change up the design quickly and re-render all these web pages to get updated images if the design or CSS changes for that HTML snippet that generates this image. So if you ever run across a feature that's similar to this, that you need to develop something that needs to have a dynamically generated image, this is a good way to do it. You can use a headless web browser. So let me show the architecture that we're going to be building to accomplish this type of workflow. So the idea here is that users who want to interact with the system can talk to a load balancer to submit a URL that they would like rendered into an image. And that URL is going to be submitted via the load balancer to a few different API containers that are listening for those RESTful API requests. And they're going to store that information into DynamoDB. They're also going to submit the job to a job queue, in this case, Amazon's simple queue service. On the other end of the queue, we're going to have some workers, a pool of workers, which are grabbing jobs off of the queue. Inside of each worker, there's going to be a headless web browser that renders that URL, and then it stores the results back into a screenshot bucket in Amazon S3, and then a user can make a request to the Amazon S3 bucket to fetch that URL. So in building this, you can see there's a lot of different components here. This is a little bit more complicated than your average Hello World application. So we're going to need some tooling to help us build all of that. And the tooling that I'm going to be using today for this demo is AWS Cloud Development Kit. So Cloud Development Kit is a new SDK that we are developing at AWS to enable advanced infrastructure as code capabilities for your application without needing to learn how to write a bunch of low-level JSON or YAML documents. There are other infrastructure as code providers out there, but a lot of them right now, they just function as a basic metadata description of what you want deployed, and then you submit that plain metadata to a service, and it creates the resources. But what if there was a way to write your infrastructure as code using the language that you're familiar with? In this case, JavaScript is one of my favorite languages for writing code in. And use a native SDK in your own language that has your editor with all of its auto-completion, all of its warnings and stuff like that. You're able to write the infrastructure code as if you were writing your own application, and in the same language, in fact, as your own application. So this is what AWS CDK is designed to accomplish. And I want to introduce some of the concepts of CDK before I dive into actually writing code for it. So here you can see the idea behind a CDK application is it's made up of multiple stacks. And inside of each stack is multiple constructs. And the idea behind a construct is it's an encapsulation of a particular AWS resource. Maybe it's an S3 bucket, or maybe it's a containerized service, or maybe it's a DynamoDB table, and all the best practices that are associated with that particular resource. So for example, maybe a construct for an ECS service comes along with its own include IAM role, its own auto scaling rules that are automatically included. S3 bucket would come with bucket policies for defining which items are private and which items are public. You get all of this for free along with your construct from CDK by just creating one construct. So let me start showing how this works once we get into the code. So starting with a fresh, brand new file, this is the best way to start code, greenfield. The first thing I'm going to do, I'm going to be writing this in JavaScript. So you can use a variety of different languages now that have CDK support. JavaScript is just the one that I wrote everything else in this particular application in. And it's one that I've used for a long time, so I'm pretty familiar with. So the first thing I'm going to do is I'm going to import the CDK package. This is an open source package. It's right there on NPM. So you can install it in your application just like you would install any other package. And it's very easy to require into your particular application code. Now, CDK has two different top-level resource types that I'm going to be using to build my CDK application, the stack and the app. And the way that I instantiate stack and app is they're just classes that are included as part of the core CDK package. So here I'm going to create a base resources stack. I'm going to create a API stack. I'm going to create a worker stack. And then to hold all of those stacks, I'm going to create an app stack, which extends cdk.app. And then finally, in order to kick everything off in this particular process, I'm going to say new app.run. So this is the basic skeleton. It's an empty skeleton of a CDK infrastructure as code application. And right now it's totally empty. There's nothing inside these stacks, but I've created 3 stacks, one of which is going to hold the base resources of my particular application, like the VPC, a cluster to run my application, any shared tables, S3 buckets, stuff like that. And then the API and worker stacks are respectively going to actually deploy that API component and that worker component. So let's see how I would use this stack. I'm going to try to deploy it right now, even though it's completely empty. It's not going to do anything particularly impressive right now, but I can use the first command. npm run script play. Okay, so this app contains no stacks. Yep. So obviously there's no stacks in this application yet, and I need to add them to my app. So the way I do that is I utilize the constructor of the application class. The first thing I need to do is I need to use super to pass the arguments down to the CDK code internally for the application. But then what I can do is I can create the substacks that are going to be part of my application by just saying new base resources. And this particular pattern I'm about to type is something you see a lot in CDK code. The first parameter is this, that defines what the parent of the resource is that I'm about to be creating. The second parameter is the name of the resource. And then the third parameter is any properties that I may want to pass down into the stack to control what gets created as part of that stack. So I'm going to take these three resources and I'm going to instantiate these stacks as part of the application. This tells CDK, I have an application that's made up of these three stacks with these names, and I would like you to create them. Okay. Let me get my spelling right there. Okay, so now if I go back over here and I run the synth command, you'll see what CDK does. It's created three files that live inside a synth folder inside my project. And if I go to these files, you'll see that they start out pretty much empty. But what this file is a CloudFormation template, or the basic structure of one. And right now, all it has in it is metadata. For these three files, all they have is a basic metadata that says this file was generated by CDK. And that's because there's no constructs inside these stacks yet. But if I start adding some constructs to these stacks, they will be created and added to that template. So let's go back to that diagram again. Actually, I can open it right here in the editor. So top level, a couple of resources we're going to need. Let's create the base resources first. The VPC that will wrap around all the networking for this application, and the ECS cluster that's going to provide a boundary. And in this case, it'll be powered by Fargate, but we're going to have a dedicated namespace inside ECS for the cluster to hold these resources. So let me go back over here. In order to utilize constructs from CDK, what I need to do is I need to include the library that provides those constructs. And all these libraries are packages right there on NPM, just like the core CDK package. So I'm going to include two packages, EC2 package and ECS package. And the EC2 package I'm going to use to create a VPC for my application. And then the other one I'm going to use to create an ECS cluster. So first of all, a network, and then an ECS cluster. So I like to create these different constructs as sub-properties of the stack. You don't have to if you want to keep one private, but I like to use this and then say something like this.vpc equals new EC2 VPC network. And you'll notice as I'm typing this, there's actually auto-completion going on in my code editor. So this is one of my favorite things about CDK. If I'm typing this infrastructure as code, it gives me hints about what I should be typing for the different parameters, because this is native JavaScript language, and the editor has capability to know what those parameters are and what their types are, and it can give me hints as to what I'm working on. So based on this, I know that once again, the first property is going to be this, aka the parent stack that's going to be holding this construct. The second parameter is going to be the name of the construct, VPC, and then the third parameter is going to be some properties. So for the VPC, there are a few properties I can specify. I'm going to choose to use the max AZs property and lower it down to 2. And I'm going to say that I only want one NAT gateway. So these are a couple of properties I can pass into the construct to control what gets created. But when this construct gets created by CDK, it's going to go out there, it's going to create 2 AZs, it's going to create one NAT gateway, and it's going to create the routing rules to hook the subnets of those availability zones up to the NAT gateway automatically. And I'm able to do that all in just here 4 lines. Let me create one more. I want to create an ECS cluster. I'm going to call it cluster. ECS.cluster. Once again, this, I'm going to call it cluster. And there's one property for the cluster, which is what VPC it needs to go into. And I'm just going to pass in that same VPC that I just created. So what we have now is we have a basic structure for the base resources. Let's go back to that CDK synth command again and see how the templates change once I synthesize them into CloudFormation again. And go back to, where is it? Base resources. Okay, wow, yeah. So here you can see a lot of different resources that have been created now based on just these few lines that I added to the code. Let's say I added like 8 new lines, but those expanded out into 250 lines of raw underlying primitive resources to create the VPC and the networking roles. I see a question in the chat. Does the EC2 VPC Network Function create one VPC with public and private subnets or just public ones? So in this case, it's creating a VPC with private and public subnets. And the way I've had it configured is going to create 2 subnets that are public and 2 that are private because I specified 2 AZs. But it's only going to create a NAT gateway in one of the public subnets, and it's going to route the traffic from the other AZs through that one NAT gateway. The reason why I did that is just to make the stack a little bit cheaper, to reduce the cost and the setup time, so I wouldn't have to provision 2 NAT gateways. So let's move on to the next step, which is I have the base resources defined. I want to add some placeholder services to my stack. I'm a big believer in using placeholder services. Rather than trying to deploy my full production service right away, I find it's easier to start by deploying a basic skeleton service that mimics what I want the production service to do, but doesn't actually have the same complexity as the production service. So in this case, for the API, I've prepared a API placeholder. And let me show you what that code ends up looking like. It's actually nothing but a tiny Express server that has a single endpoint for the load balancer to talk to. And it just returns the string placeholder up and running, and it listens on a port. So I can take this particular placeholder application, and if I go into that folder, API placeholder, I can run it. Whoops, I need to specify port. And once it's up and running, I can send some requests to it. Make this bigger. Okay, and I get a response back. So this is very simple. It's just a few lines of JavaScript, and it returns some logs here. Now, the next thing is I want to deploy this as a container, because I do know that eventually the application is going to get more complicated and it's going to have different dependencies that need to run. So let me show you how I do that. I have a Docker file that I've built, and this Docker file is a multi-stage Docker build. You'll notice there's 2 sections to this file. The first file is the build stage, and what it's doing is it's pulling an entire Node.js 12 environment, and it's running the npm install to get all the packages from the registry, and then it's taking the Node Slim environment and it's copying my code in there and running it. So I can go back over here. I can do Docker build, and just like that, it's built my Docker image, pulled in my dependencies, and created an image. And it's giving me an image ID. So now I can run this image locally. I want to run it with a -D flag for detached. I want to specify a port that it's going to listen on, and substitute my package or my container ID, and boom. If I do Docker PS, I see that I have a container running in the background, and I see that it's mapping port 32771 on the host to the container. So I can say localhost 32.771. I can send some requests, and once again, I get placeholder up and running. Except now my code is actually running inside a placeholder container instead of directly on my laptop. And I can also say, give me the logs for this container ID. And yep, I can see my logs for this container. So I'm just going to kill this container real quick. Make sure it's dead. Yep. Okay. Now, all these steps that I just did in order to build the container locally, I want to automate those. I don't want to have to do that by hand every time I release my application. And fortunately, CDK can handle that for me. So let me go back to my CDK application. And the way I do that is, once again, I'm using the ECS construct. Now, there's a very fantastic API construct that works great for web applications, RESTful APIs, anything that you may want to deploy that has a web server and needs to answer requests from the public. And it's called the load balanced Fargate service. It's a top level construct of the CDK. You can see I'm going to use the autocomplete here, load balanced Fargate service. I'm creating it in this stack. I'm going to create it as the API, and I have some parameters. Now, the first parameter is the cluster that I want to deploy it into. Now, you might notice I created the cluster in a different stack of the application. I created the cluster over here in this base resources stack, but I want to reference that cluster inside of the API stack. And fortunately, there's a good way to do this. You notice I created the cluster as a property of the base resources stack, which means that it's accessible up here at the app level. And that means I can take that particular property and I can pass it in as a property on my stack over here. I can say this base resources dot cluster. I see a question in the chat. In CloudFormation, it's not supported that you have SSM parameters in the ECS task definition container. You have to create a custom resource for that. Is it possible to do that with the CDK code? Unfortunately, right now, yeah, you're right. CDK can't do anything that CloudFormation can't do. It does do some extra things as Lambda functions, but in general, CDK is limited to what CloudFormation has support for. Fortunately, we're working on improving the CloudFormation support as quickly as possible. So there may be some gaps in feature between the time that we release a feature for ECS and when it becomes available in CDK. But we're working on filling those as quickly as possible. So once again, to recap, what I did was I took my cluster from the base resources stack and I'm passing it in as a property to the API stack. And once it's passed in, I can use that property. Now, this is one of the coolest things that I really like about this is it'll automatically create an export in the one CloudFormation template and automatically create an import in the other CloudFormation template to pass this resource along. Another great helper that is part of the ECS construct is a helper to build a container image. So here I'm going to build an image from asset, and what that means is I want to take a local Docker file that's on my development laptop, and I want to build it and push it to AWS, and then I'm going to use that that image for my application. So here we go. What am I missing here? Oops, missing that. Oops. Okay. So I'm building this image from the asset, which is that Docker file in that API placeholder folder that I showed earlier. For the service, I wanted to launch 2 of them. I want to specify how much CPU is going to take. I'm going to specify 256 as the CPU. That's roughly a quarter of a core. Then memory, I'm going to specify 512 megabytes. This is one of the smallest Fargate containers that you can run. And I'm also going to specify create logs. So this is very useful because this high-level API construct now is complete, and what it's going to do is it's going to build the image locally on my host. It's going to put it into that cluster. It's going to put 2 of them in the cluster, and it's even going to automatically create a log group in CloudWatch and pipe the logs to it. And all of that accomplished in maybe less than 10 lines. It's going to, oh yeah, it's also going to automatically create a load balancer and direct traffic that goes to the load balancer to that service. So let me just double check. I like to rerun synth every once in a while to just check to make sure I didn't have any errors in my scripts, because it'll do some type checks and everything on my JavaScript to make sure that I didn't make any mistakes when I was using these constructs. So here I can go in and let's look at this again. Okay, yeah, so now with the API template, it went from being just nothing but metadata to being a fully fold out detailed description of an ECS service with auto scaling, a hooked up load balancer, security groups, and their final output is going to be the URL of that load balancer. Now, so that covers a basic structure for the API. Now, what about the worker? So I also created a placeholder for the worker. And what I intend is for this worker to be listening to work in the background and picking it up off a queue automatically. But that means that there is no web server for this. So instead, what I have is I have a basic skeleton that does nothing but output every 2 seconds checking for work. Okay, so this will be a placeholder for that. And I want to add this to my application as well. Obviously, I'm not going to use the load balanced Fargate service construct because there isn't a load balancer. It needs to be connected to this. Instead, I'm going to create a service from scratch. So this is going to show you that there are multiple different levels of constructs that you can create. I can use a very high level construct like the load balanced Fargate service that creates a lot of different resources. Or I can use some of the slightly lower level ones that give me more raw access to the underlying configuration that's available with ECS. So here what I'm doing is I'm creating a task definition. And if you're familiar with ECS, you'll know that a task definition is just a document which describes what your application is and how you would like it to run. And so at the top level, I'm just saying my application is a container that needs 2048 CPU, aka 2 cores, and it needs 4 gigs of memory. And to this, I want to add a container. So I'm going to say this.worker definition, and there's a nice helper method on this particular construct called add container. I'm going to call the container worker. And once again, there's an image. I'm just going to go ahead and copy this code from up here because I'm lazy. I don't want to retype this. And I'm going to call this the worker placeholder and worker image. I see a question in the chat. What's the nice placeholder history display you've got going on in the terminal there? Look up ZSH. It's actually a shell, yeah. And I have like Powerline installed. I have the Menlo font for Powerline. There's a few different configuration I have set up in there, but I highly recommend ZSH. I don't know how you're supposed to say it, but it's a fantastic terminal experience. Okay, so let me specify some more parameters for this container that I'm creating. CPU 2048, memory once again 4096. And you can see that since I'm using a lower level construct here, I do have to do a little bit more typing because that higher level construct, that load balanced Fargate service, was doing a lot for me automatically. And I don't have the luxury when I'm using a lower level construct of letting it do things like automatically create my logs for me. But the flip side of that is it does give me more control over what gets created because I have access to those raw underlying parameters. Now, okay, this error can be resolved. And so now I have a worker definition that has a container inside of it. And the last thing I want to do is I want to create a service out of it. Question: how does ECS container image from asset work? I'm about to show that when I actually deploy this. So let me finish typing out this Fargate service, and then I'll run the CDK deploy, and you'll get to see exactly what it does. But you're correct; it's going to build that container locally. then it's going to push it up to ECR automatically, and it's going to automatically deploy the service referencing that ECR image. So once again, I need to specify the cluster I want it to run in, count of 2, and in this case, rather than deploying the image directly, I'm going to deploy this task definition, because the task definition has the full definition of everything I want created. Okay, let's double check, make sure I didn't mess anything up. So make sure it's synthesized. Okay, oh, yep, I got an error here. There's already a construct with name worker. Okay, yeah, I know what I did here. Which one is it? Yep, I added a worker as the task definition and worker as a service. So each of these things inside of a stack does need to have its own name. That's easily solved though. I can just call this a worker definition and the service will be worker. Make sure this works. Okay, yeah, so everything's synthesized. And if I go into my stack, I'm going to see that the worker is now also filled out with a good almost 350 lines of CloudFormation template. So it's time to deploy this. But before I deploy it, I want to do one thing. I want to do a run script diff. I want to see a preview of everything that's going to be deployed. And so what I see here is it's detected 3 stacks on my application, and it's listing out all the resources that are going to be created. You can see in the base resources stack, all the VPC and networking related things and outputs that are going to be added. So that way I can reference those VPC networking things in another stack. I can see a bunch of roles, IAM roles that are going to be created automatically. Once again, this is one of my favorite things about CDK. I don't actually have to create all these IAM roles by hand. I don't think anybody really likes going in there and messing with IAM roles directly. So this saves me from that challenge. I see in my second stack all the service-related things, and finally in my last stack I see even more service-related things. So fingers crossed. Let's hope this works. I'm going to run the deploy now. And we're going to see this start to deploy. It's deploying the base resources stack right now. It starts out by creating a CloudFormation change set just to make sure that there's nothing that's going wrong if CloudFormation might reject the stack. And then what it does is it starts deploying resources. And you see it gives me a live log as it creates things. You can see 0 of 24. So there's going to be 24 resources in this base resources stack, expanding out from just the 2 constructs that I put in there. And you can see it starting to count at 1, 2, 3, 4 as it creates those different resources. Here's a question in the chat. How do you get your terminal to show the colors over the PS1? I'm just using iTerm, and so it comes with built-in color support, and then the shell that I'm using has the default color scheme. I did customize it a little bit because I like to have that dark background and the faded view. But yeah, it was pretty easy. I don't think I had to customize too much. So while this is deploying, let me go into the console and let's see what it's doing underneath the covers. You'll see that it created a couple CloudFormation stacks, and right now it's deploying the base resources stack. So this is really, it's using CloudFormation under the covers. I just don't have to touch the CloudFormation by hand. Ideally, my philosophy when I'm using AWS is that I like to use the console as a read-only interface. Ideally, everything should be created by infrastructure as code, and I'm just using the console to view what got created. And so CDK helps me out with that because rather than having to write a bunch of CloudFormation by hand, CDK will let me write just a few lines and we'll go ahead and create that automatically. So while the placeholder services are deploying, let me introduce the real services in their code. I deploy the placeholders just to make sure that I'm going to be able to deploy a service, but let's look at some of the more complex code that's actually going to be deployed once I'm ready for that. So let's start by looking at the API. And here's the code for that. Oops, not this one. That's the placeholder. It's this one. So you can see that the real API, it actually isn't that much more complicated than the placeholder. It's still only 73 lines. The main thing is that it has two new routes on it. One of them is post a job, and the other is get a job and specify the job ID to get the results of a job. And you can see that inside this handler, what it's doing is it's inserting an item into the database, and it's setting a message to a queue. And then when I'm getting the job, all I'm really doing is I'm reading out of the database. So this is very, very simple. On the other side, in the worker, this is where the magic really happens. I'm using the Puppeteer package. This is a great package on NPM that allows you to interact with headless Chrome using an async await interface inside of your JavaScript. And the other thing I'm using Squish. This is one of my favorite packages for high performance polling of an SQS queue. I've tested this up to hundreds of messages per second. But what it does is it gets all these messages off the queue, and it kicks off a job. It updates the status in the database. It launches a headless browser, takes a screenshot. It uploads that to S3, and then it does a final update on the status in the database. And once again, this worker, it actually ends up only being 124 lines. So this is a fairly basic setup. I don't have to write a lot to actually make this work. Some of the more complex things are actually in the Docker file for the worker code. You can actually see that I've had to install Google Chrome inside of the Docker file. And we'll see in a little bit when I actually substitute this in what the complexity is on that in terms of size and everything. I just saw a question. If your database is specified with CDK, how would you upgrade database version or change instance size without destroying data? So good question. Fortunately, I don't have that problem because I use DynamoDB. Everything that I want to update with DynamoDB can be updated using the API. I'll actually show when I set this up. Now, if I was using Aurora, there's also ways to do a zero downtime and update on that. You'd have to look in the documentation for that, but it shouldn't be a problem either. In general, CloudFormation does do the right thing. You may need to be very careful with RDS. Aurora is a little bit easier. Okay, so let me go back to my application code and look at this architecture diagram again. Obviously, I'm going to have to add some new constructs to make this work. I'm going to have to add that S3 bucket, that SQS service, and that DynamoDB queue. So let me show how I'm going to do that. First, I got to import those packages. So S3, SQS, and DynamoDB. S3, SQS, and DynamoDB. And I'm going to be creating the resources in my base stack because I don't want to have to recreate those resources if I change something in my application, or if I want to even delete my application entirely. I don't want my database table to be deleted just because I deleted my service, for example. And what's more, this table, for example, is going to be shared across multiple services. So it makes sense to put it in one parent stack and then reference that same table in the other two stacks. So let me start by creating the bucket. So s3.bucket. Actually, before I start typing this, let me go back. Let me look at this, make sure it's still creating things. Yeah, okay. So here you can see it's currently working on deploying the API, and you can see that CDK automatically built and pushed my image, and then it created a CloudFormation change set that referenced that image, and now it's currently deploying that service out. Okay. Go back up here. I'm going to start adding some more resources. So I'm creating it in my parent stack. I'm going to call it bucket. And one more thing, I want public read access on this. I want people to be able to access those screenshots. Queue. This one is easy. I don't really need any parameters for that at all. That's just going to go ahead and create a queue for me. with all the proper settings that I need. And then finally the table. This one gets a little bit more complicated because I have to pass in some properties that pertain to DynamoDB and how it works itself, which is the key that I'm going to be using for looking stuff up inside of the database. Unfortunately, as I mentioned before, there's some excellent autocomplete in CDK, so it helps me to find the properties that I need. So I want to create an ID property, and I want it to be a string attribute type. So there we go. And I also want to set a billing mode on this table. I don't want to have to worry about capacity provisioning at all. So I'm going to be using the billing mode, which is pay per request. Nice. Okay, so I added 3 new resources to the parent stack: bucket, queue, and table. I need to pass those resources in to my actual application stack. So let's do this: table equals these resources table, and queue. Okay, and then the worker needs access to the table and queue as well, but it also needs access to the bucket. Okay, so let me switch out my code for the API with the real API. And the way I've chosen to configure my application is via environment variables. So the environment variables specify where my container can find those resources that I've created. So I'm going to pass them in by directly referencing a property of the construct that was created in the other stack. And the amazing thing about CDK is it automatically resolves this reference. So it's going to locate that other resource in the other stack, import it, and find that attribute of the queue URL and put it in there as an environment variable inside of my task definition when it deploys that service. And I can do the same thing for the DynamoDB table with the table name. Now, one thing you might wonder is, well, how is my application going to have permission to actually talk to this queue in this table? Well, fortunately, there are helpers for that. So once again, I can reference the queue, and I can use a method called grant send messages. And I can specify the role that was automatically created as part of my service construct. And I can do the same thing for the table itself, except the helper method for that is grant read write data. And so what this is going to do is it's going to automatically create the IAM rules that will allow the API to send messages to the queue and allow the API to read and write data to the table. This is so much superior to manually writing IAM permissions. I mean, once I started using this, I couldn't go back to handwriting IAM permissions, because this automatically has the default limited subset of permissions that are needed to send messages, but not necessarily delete them off the queue. But then I can use a different method on the other side for the worker. So once again, I'm going to switch that code over from the placeholder to the real worker. I am going to add environment variables so it can find the resources. Bucket. Whoops, I need to get that. I need to get those properties right. Queue table. Okay. This is looking good. Just a little look it over and make sure I didn't mess anything up there. Okay, it looks good. And once again, I have to add some permissions down here for IAM permissions. I'm going to start by copying this up here, because I already typed that out. I'm going to have to change it a little bit. In this case, I was referencing a task definition that was automatically created by that construct. Except now I'm using a task definition that I manually created as a manually created task definition construct. So instead, I'm just going to refer to that worker definition directly. And the queue consumer that's going to be reading off the queue, it doesn't need send messages, it needs consume messages. So here I've automatically created minimal permissions. The worker is going to have permission to pull things off the queue, but not push things on. And then the API is going to be able to push things on the queue, but not pull things off the queue. And I need to add permissions to talk to the bucket. So grant read write on that bucket. And that should do it for deploying the application. Let me switch back over here. Okay, great. So my placeholders have actually deployed now. And I have a URL for the application. So if I go over here and load up that URL, boom, placeholder up and running. I get a little message. Placeholder up and running. Okay, so let's switch that over to the live application now. First things first, I'm going to run the CDK synth command just to make sure there's no obvious mistakes. Whoops. And yep, it looks like they were able to synthesize the CloudFormation correctly. I'm going to run the diff command to make sure that the list of resources that are going to be created match what I expect. I love this command because I'm able to see at a high level all the new things that are being added. So I can see there's a bucket added, a bucket policy, a queue, a table. I can see exports being added. And importantly, I can also see these IAM statement changes. So I can see that my API is getting these new permissions to talk to the queue, to talk to the table. And I can see that my environment variables are being added to my task definition. So all of this is really beautifully done. I think the team did a great job on making it very clear what's going to be added to your infrastructure and very easy to interact with. So let me kick off the deploy now. All right. Now, while this deploys, let me switch over to the ECS console and show what's going on inside that console. I can see my cluster, and I can see some running tasks in there. And once again, I like to treat this as a read-only interface. It's not particularly easy to create tasks by hand in the console. I know a lot of people, when they first start out with ECS, they try to use the console to create resources. But what ends up happening is there are a lot of settings involved with a container, and you have to get all the ports right. You have to get all the settings correct. And you can easily end up misconfiguring and going through a lot of pain and frustration trying to iterate through and get all your settings correct. I find it's easier to use a higher level framework such as CDK because it automatically sets a lot of those settings for you. And then I just use the console to view and verify that everything did deploy as I expected, and that I have, in this case, 2 of the APIs running and 2 of the workers running. These are actually the placeholders, though, not the real service. The real service is currently deploying right now. So you can see it added those new bucket and DynamoDB table to the base resources stack, and now it's building and pushing the API. And I'm going to show you a little trick once this starts deploying that you can use to speed up your ECS deploys a little bit when you are deploying them. By default, ECS tries to be very, very conservative about how it switches over tasks. But it is possible to do it a little bit faster than default settings. So I'll show that once the new task comes up. A comment. ECS was a pain in the beginning with setting up, but really happy now it's running. And so that's good to hear. What I like to tell people is ECS, a lot of the frustration is initial setup costs, but initial setup costs are one time. Ideally, you have a one-time setup cost to get your cluster up and running and get your application into the cluster. But then from that point on, it's going to save you a lot of time and effort because it's going to keep your application highly available. It's going to keep moving it around to newer instances. Like if an instance type gets removed from your cluster because you want to upgrade, it'll automatically move to your next instance type. There are just so many benefits of using ECS once it's set up. And we are working on making that initial setup period easier. And one of the tools that we're using to do that is the CDK tool that I'm showing right now. So definitely feel free to also reach out to the team if you have any feedback on things that were more complicated than you felt they should be and that we could be working on. So currently it says update in progress on the ECS server. So I'm going to show you a little trick to speed this up a little bit. So as I mentioned, by default, ECS wants to keep you with 0 downtime on your deploys. So it keeps an older version of the container running in parallel with your newer version to make sure that there's no loss of traffic. But I'm going to YOLO this because I don't really care about this. It's not really production traffic. So I'm just going to go ahead and stop the older versions of the task and make sure they get terminated without actually waiting for 0 downtime, and just leave the new ones running. And so when it happens, it's going to cause that deployment to go a little bit faster. And if let's see, where's my URL for the, well, I can go in and get it. If I go to services, EC2, I'm going to hit the URL for my application again and show how this works. Load balancers. Question, out of interest, why aren't you using Fargate? I actually am using Fargate. So a lot of people, when they see ECS and Fargate, they get a little bit confused about the difference between the two. So you actually currently cannot actually use Fargate by itself without using ECS. And the reason for that is that ECS is the administration API that you use to say, I would like to deploy this. Fargate is the underlying hosting layer that actually runs the containers themselves. And so what I'm doing is I'm using ECS to orchestrate the deployment, and I'm using Fargate to actually run the containers that are inside of the deployment. So you notice if I look into the code again, I created a load balanced Fargate service, and I created a Fargate task definition. And so that was all I needed actually to switch from EC2 mode to Fargate mode. And that's how it worked. Okay, so I got my load balancer address here. I'm able to hit that, and I see that the message changed from placeholder up and running to up and running. So I know that API is there and available now. So let me switch to my HTTP client. I like to use PAW. I'm not sure if you're familiar with it, but PAW HTTP client. It's a really nice, slick interface that allows you to set up all your requests and send the requests to your application easily to make sure it works. So I'm going to send a request to create a job to render reddit.com. And check job. So currently it says that the status, let me see if I can't make that any bigger, unfortunately. But the status says that the job is submitted. And that's because the worker is not done deploying yet. If I switch back over here to the tab that's currently running CDK, you can see that it just finished building my worker image and pushing it. But if I go over to the console and I load up the DynamoDB service, look at the table that I created earlier as part of my base resources and look at the items in there, I'm able to see that URL that I submitted is currently in the database with a status of submitted. And as soon as my worker is up and running, it's going to grab that job and start working on it. This is going to take a few more minutes because, unfortunately, the image for the worker is quite large. If I switch over to ECR, you can see that the worker image, the first placeholder was only 55 megabytes. The actual production worker that has Google Chrome headless in it is just over 600 megabytes. So that's a beefy image. It has a lot going on inside of it. While I'm waiting on that, let me look back at the chat. I see some talk about Fargate costs. Yeah, we did lower the prices on Fargate by up to 50% at the start of the year. So according to some of the research that I've seen done, um, Fargate can actually be cheaper than EC2 for the vast majority of workloads. Let me see if I can find this. Pricing in context, Truck 10. This is a really great article that somebody at Truck 10 made about Fargate pricing. And what they determined is that break even between Fargate and EC2 happens in the 60 to 80% reservation rate. So what this means is when you're running a cluster of EC2 instances, in order to get your money's worth out of them, you have to keep them utilized. You have to keep that CPU busy, and you have to keep that memory full of things. And so you have to run a lot of applications on those EC2 instances. And so if you're running an EC2 instance 24/7 and it's not being utilized, you're essentially wasting money. Versus in Fargate, what that allows you to do is launch a small container that more accurately matches the size of your task, and you don't pay for any of that extra space on an EC2 instance that would otherwise be going to waste. So their conclusion once they did the cost analysis is that if your cluster is only 50% utilized, you might actually see a 10 to 20% cost reduction with Fargate. So definitely look into it. I find that the vast majority of people who are running on EC2, especially smaller companies, they don't tend to get good utilization out of their EC2 instances because they don't have enough traffic to fully utilize an EC2 instance. And so for them in particular, switching to Fargate would be a big cost savings because it would allow you to downsize the amount of resources that you pay for versus the amount of resources that you're actually using. Okay, wow. So while I was chatting, the worker service deployed, and we can see that according to the database, it's showing the job is showing up as done. Let me go into ECS and verify that my tasks are running the right definition. Yep, and there's only 2 of them. So that means now I can now go to my HTTP client. I can submit a job to take a screenshot of Reddit. I can check. Okay, it says the job is started. Let me keep going. Reddit's a pretty big website, so it takes a little bit of time. I find the headless web browser for small websites is done in less than a second. For some of the websites that like Reddit that have more, there we go. It took a screenshot of the Reddit homepage, and that looks like that is indeed Reddit right there. A nice big high resolution screenshot of the current status of Reddit. So yeah, everything's working. And the cool thing about this is it will automatically scale. So it will horizontally scale to increase the number of API workers and the background workers as needed in order for everything to work. So I'm pretty excited about this particular CDK workflow and how easy it is. One of the things I'm going to do is I'm going to go ahead and open source the code that I used for this demo application, so that way you guys can take a look at it as well. Please type the name of the Nathan Pack screenshot service. Whoop. And I'm going to go ahead and make that public for you. Okay. All right, so see if I can drop this into the chat. GitHub.com, Nathan Peck, screenshot service. Give that a look. That's the raw code that I used for this particular application. You can take the CDK templates and deploy them yourself, or you can just take the raw code for the worker and API and test out deploying it with a different tool as well. I hope this has been a useful learning experience, and feel free to reach out if you have any questions, or go ahead and ask them in the chat right now. I see one question. How do you envision the CI/CD pipeline of the applications with CDK? So the CDK is just a JavaScript tool which runs on any machine that has Node.js installed on it. So for the CI/CD pipeline of CDK, I would set up Probably a code build or Circle CI or any other CI/CD provider that has JavaScript and Node.js support, and I would run the Node.js code of the CDK on that machine. So for example, if I was doing Circle CI or code build, I would just add to that repo a top level file which said, for the build, I would like you to run npm install, because you would have to run npm install first to install these prerequisite packages that are used by CDK. And then the next command would be to actually run this command from the npm file, the npm run script deploy, which runs CDK deploy require approval never. So that's what the CI/CD server would be doing, is it would literally be building the CloudFormation template on the fly and deploying it to the AWS CloudFormation once it ran that CDK deployment. Any other questions before I sign off here? I'll give everybody a chance to ask if there's anything else you're curious about ECS, containers, or the AWS Cloud Development Kit. All right, well, it looks like I have answered everyone's questions then. Once again, feel free to reach out to me on Twitter. My Twitter is Nathan K. Peck. If you have any questions at any time, and there's the link right there. Whoops, there's a link. And I'm always answering ECS questions, CDK questions. I also even answer Node.js questions sometimes. And enjoy your journey of building applications and deploying them on AWS. Thanks a lot.